Hello, in this video I'll be covering the order in which beta amyloids and tau tangles spread in the brain for Alzheimer's disease. Also note that this is part 2 of a series of videos that investigates the true nature of Alzheimer's disease. You can find other videos and supplementary information in the description below. In Alzheimer's disease, the amyloid plaques and tau tangles start forming in the entorhinal cortex, spreads to the hippocampus, and then to the adjacent brain regions such as the temporal and frontal lobes, and finally the cerebral cortex, and then to the rest of the brain. The aftermath is a total decay of the person's brain. If they reach such a stage, they will have a level of intellect akin to a baby. And finally, the person would usually die because their bodily functions shut down as the parts of the brain related to their functions rot away. Because the Alzheimer's disease starts in the entorhinal cortex, the entorhinal cortex is the first to be affected by Alzheimer's disease. Alzheimer's disease impairs the neural connections of the entorhinal cortex region, causing the entorhinal cortex to malfunction. Before I continue, first know that the entorhinal cortex is a densely interconnected region of the medial temporal lobe that connects to the hippocampus and other brain regions. The entorhinal cortex has functions related to spatial navigation. For example, one region of the entorhinal cortex is populated by grid cells, a special type of neuron that specializes in vector mapping 3D space around the organism. So, Alzheimer's disease would cause impairment to the transfer of information through the entorhinal cortex to the hippocampus and other brain regions, impairing spatial navigation, harming the 2D map-like spatial navigation of the entorhinal cortex, such that a person would become prone to spatial disorientation. The next target after the entorhinal cortex is the hippocampus. The function of the hippocampus includes the formation of spatial memories and long-term memories. In other words, the hippocampus is the part of the brain that enables us to learn new things. This process of learning new things may also be known as the consolidation of short-term memories to long-term memories. So when Alzheimer's disease starts affecting the hippocampus, the person becomes impaired in the formation of spatial memories and new long-term memories. In other words, an Alzheimer's disease patient would experience spatial disorientation and start losing things in their places, become lost more easily, and have a harder time learning and remembering new things. For example, he or she may forget where they just put their car keys, get lost while driving or shopping, forget what they had for breakfast, forget things that they had just done, and the name of the person that they had just talked to. This is very important because Alzheimer's disease patients may also forget the medications that they have just taken. Then Alzheimer's disease hallmarks such as tau tangles and beta amyloid plaques spread to the adjacent temporal and frontal lobes, and then the cerebral cortex, and then the rest of the brain, thereby disrupting their specific functions such as speech and executive function, like a person's ability to make judgments. The person also will experience an erosion of their past memories, thereby forgetting their past history. In this way, an Alzheimer's disease patient loses their identity and eventually die to Alzheimer's disease as their brain-dependent bodily functions shut down. This is the end of part 2. In part 3, I will explain what beta amyloids, their functions, and their consequences in Alzheimer's disease are. Thank you for listening. If you have any questions, please feel free to ask them in the comments below. I'd appreciate if you like and share this video and subscribe to my channel. Bye!